Welcome all to Basic Maths class 21. In this class, basically we'll discuss about integration by substitution. If you like to integrate a function, something like let's say integration of 2x plus 3 raised to 3. So into dx. So we know that if it is in the form of x raised to 3, then we know how to integrate it. Or if it is just integration of 2x plus 3 dx, then we know how to integrate it. But if it is 2x plus 3 raised to 3, then we don't know how to integrate it without expanding this. So in such a situation, what we'll do is we'll just consider this function, or you can just take it as something but this internal function. We'll take this 2x plus 3 is equal to nothing but t. We'll consider it as a new variable. Now we can write the equation something like this. It becomes integration of 2x plus 3 taken as nothing but t. So it is t raised to 3 into dx. But we know that it is not possible to integrate t with respect to dx. So, or with respect to x. If it is t, if you like to integrate t, then it should be dt over here. Or if you'd like to integrate with respect to x, then it should be in the form of x raised to something. So we cannot integrate t with respect to x. So what we'll do is we have to change this term dx over here and we have to write it in terms of dt. For that purpose, we'll differentiate like on this equation. We know that it is t is equal to nothing but 2x plus 3. So if you are differentiating this equation, we'll get a term dt. So we can write dt is equal to 2 into dx. That means instead of this dt, instead of this dx, we can write this dx is equal to dt divided by 2, and we can substitute this value over here. So our integration will change. It becomes integration of t raised to 3, and instead of dx we can write this will come equal to dt divided by 2. Now it is in the direct form of integration, that is we can write 1 by 2 into integration of t raised to 3 dt. So we can write this is equal to half is a constant into t raised to 3, which is t raised to 3 plus 1, that is t raised to 4 divided by 4, plus constant of integration, that is c. So we can write this is equal to t raised to 4 divided by 8 plus constant of integration c. So this one is the way we'll integrate a function if it is not in direct form of integration. Over here the value of t is taken as nothing but 2x plus 3. So we can just resubstitute it. 2x plus 3 raised to 4 divided by 8 plus c will be the value of, will be the final answer. So we can write integration by substitution is nothing but when integrand is not in direct form of integration, then a part of it is substituted by a new variable to transform the integrand into direct form of integration. Then the results of direct integration can be used. Means if I'm explaining the statement based on the question that we discussed that it is integration of 2x plus 3 raised to 3. So over here this integration is not in direct form of integration. So the thing which that we are going to integrate is known as nothing but integrand. So over here this is nothing but our integrand 2x plus 3 raised to 3. That is not in direct form, means it is not in the form of x raised to 3. So in this situation a part of it is substituted. So over here a part of it is taken as nothing but 2x plus 3 is substituted by a new variable. Our new variable is nothing but t, to transform the integrand into direct form. Means if I am writing it in the form of t, it is in the form of t raised to 3 into dx. Then we wrote it as this t is equal to nothing but 2x plus 3. Then we can write this dt is equal to nothing but 2 dx. So we can write this dx is equal to dt divided by 2. So while replacing this dx by dt by 2, we'll get it as it is integration of t raised to 3 into dt divided by 2. Now it is in direct form of integration. So that we are writing over here integrand into direct form, then the results of direct integration can be used. Now it is in the form of x raised to n, so we can directly go for x raised to n plus 1 by n plus 1. Let's say we are taking another example. It is integration of sine 3x dx. Over here we know how to integrate sine x, but we don't know how to integrate sine 3x. So over here also integrand is not in direct form of integration, then a part of it. So over here our internal function is nothing but 3x. This can be substituted by a new variable. We can take it as nothing but t. So we'll write it as sine of 3t can be written as nothing but t into dx. Over here this t is nothing but 3x. Now we can just differentiate this equation so that we'll get the value of dx in terms of dt, that is dt is equal to nothing but 3 dx, or you can write the value of this dx is equal to dt divided by 3. Now we can replace this value over here, so we can write this is equal to nothing but integration of sine t dt divided by 3. Now it is in the direct form of integration. So we know that 1 by 3 we'll just take it as a constant. Integration of sine t is nothing but minus cos t plus constant of integration that we can take it as c. So this will be our final answer. Just remember that differentiation of sine x is cos x or cos x dx, but integration of sine x is minus cos x. So we can write this will be equal to minus 1 by 3 into cos of t was nothing but 3x plus constant of integration c. We'll take another example. Let's say if it is given that integration of 4x plus 5 into dx. So again over here you can write this 4x plus 3 will take this 4x plus 5 is equal to nothing but t. And then the next step is we have to differentiate it. So we can write it as 4 dx is equal to dt. So that we'll get the value of this dx in terms of dt, that is equal to dt divided by 4. Now we can rearrange this equation, that is integration of 1 divided by 4x plus 5 is taken as nothing but t, and dx can be written as dt divided by 4. So we can write is in the form of 1 by 4 is a constant, it is integration of 1 by t dt. We know that integration of 1 by t dt is nothing but ln of t. So you can write it as 1 by 4 into ln of t plus constant of integration c. Or you can write the final answer will be equal to 1 by 4 into ln of this t was nothing but 4x plus 5 plus constant of integration c. So this will be our final result. Now we'll take another example. If it is given that integration of e raised to 2x plus 7 dx. So over here by our substitution method, what we'll write is first we'll write this internal function, this t is equal to 2x plus 7. Now we'll differentiate it, so we'll get the value of dt is equal to nothing but 2 dx, or you can write the value of this dx is equal to nothing but dt divided by 2. Now we'll rearrange this equation. It becomes integration of e raised to 2x plus 7 is taken as nothing but t, and dx can be written as nothing but dt divided by 2. So you can write this will be equal to 1 by 2 into integration of e raised to t dt. We know that integration of e raised to t dt is nothing but e raised to t. So we can write this is equal to 1 by 2 into e raised to t plus constant of integration c. So we can write this final answer will be equal to half into e raised to t is taken as nothing but 2x plus 7 plus constant of integration c. Now we'll discuss about a shortcut method by which we can find out the answer directly without doing this much calculation. So over here our first question was integration of 2x plus 3 raised to 3 into dx, and our aim is to find out what about the value of integration of this. Over here you can just consider that this internal function as nothing but x. Assume that 2x plus 3 as nothing but x. Now you just consider that it is like x raised to 3. So we know that integration of x raised to 3 is nothing but x raised to 3 plus 1, that is 4 divided by 4. Now over here we consider that x is nothing but 2x plus 3. Now what we have to do is we have to just differentiate this function and divide it by the same value. That means if I am differentiating this 2x plus 3, so differentiation of 2x is nothing but 2. So whatever the answer you are getting, just divide this by that result plus constant of integration c. So you'll get the answer as nothing but 2x plus 3 raised to 4 divided by 8 plus constant of integration c. So we can directly get this result. Got it? But just remember that we can apply this equation only if it is a linear function. That means it should not be like the power of x should be equal to 1. It cannot be like any other value than this 1. Same, we can continue for the next question. That is, in the next question it was integration of sine 3x dx. So again, you just assume that this 3x is nothing but x, and we can write integration of sine x is nothing but minus cos x. So it becomes minus cos of x. X we consider it as nothing but 3x. Now we have to differentiate this and divide by the value. So if you are differentiating 3x, you will get the value as nothing but 3. So we'll divide it by 3 plus constant of integration c. So we'll get the this result directly. Got it? Now you can go for the next situation. There is integration of 1 divided by 4x plus 5 into dx. Again, you just assume that this is like 1 by x. So integration of 1 by x can be written as nothing but ln of x. So ln of over here x is nothing but 4x plus 5. Now we have to differentiate this equation and divide by the value. So differentiation of 4x plus 5 is nothing but 4 plus constant of integration c. So we can directly get this result. We'll take that final example. It was integration of e raised to 2x plus 7. So we can write this e raised to 2x plus 7. This 2x plus 7, just assume that it is like x. So integration of e raised to x is nothing but e raised to x. So we can write it as e raised to x. That is, x is taken as 2x plus 7. Now we have to differentiate this term and divide by that value. So integration of 2x, differentiation of 2x is nothing but 2 plus constant of integration c. So we can observe that we'll get directly this result. But just remember that this method is valid, direct method is valid only when if it is a linear function. Hope so that you understood this topic. If you are having any doubt, or if you'd like to interact with me on live classes, or if you want to write online test for JEE Mains, Advanced or Neet, or if you want to solve more questions, then please let me know. Thank you.